Alright, so beginning the process of building a SOLN1. The first thing you'll want to do once you get your panel is you'll want to clip these wires. So go ahead and leave the labels. These panels come with a positive and negative label, and that can be useful later on. So go ahead and just clip the wires, and we'll leave it at that for now. You'll notice on the positive line coming out here that they've got this box here. Inside here you'll find a diode. So don't worry about destroying this, but we're going to get in here and we're going to desolder this diode. And we'll pop this little guy out, and we'll go ahead and we'll use it in our system. So we're just going to tear this little assembly apart here. We're going to desolder the diode off here. You want to save this diode because this diode's already been spec'd out to work well with this panel. We already know that. The little color band on it goes this way because we want to take the energy coming this way, and we don't want the energy coming back this way. So go ahead and put the color band facing forward. We're going to solder this diode onto this positive line coming up here. Okay, so I'm going to take the diode and I'm going to basically split some of these wires up and slide it up inside there like that. And then just solder this guy into place. You want to make sure that the solder gets drawn up into the wiring. You don't want any cold joints that are going to be cracking on you later. So if you put your soldering iron on this side, you ought to be able to touch the solder on the other side, and it gets sucked all the way through. So that's exactly what happened there. Alright, so we've got this soldered into place. The next step is going to be to cut some Velcro tabs for the back of our battery pack here. So when we get these tabs all cut out, we'll put them on the back of the battery pack, and we'll secure this battery pack here in the back of this solar panel. So that's the next step. So we've got all the Velcro on here, and we're just going to put this pack in. We're going to put this way with the wiring coming out the top right here. So just like that. So that's in there, very secure. And beyond that, the ABS backing on here, then will be very, very secure. So now the next step we need to make is a Y wiring harness. We're going to come off this, and we're going to Y. So we're going to go ahead and start to build our wiring harness here. One thing to note is we're using these XT60 connectors. I really like these connectors. You can get them from Hobby King at a very reasonable price. And what I'm going to do here is I'm going to connect on to here. I just want to point out, you really don't want to just, obviously most of you probably know this, but somebody may watch this video and try to build one of these and just go and cut through the wires. Not a good idea. Anytime you're doing connections, go ahead and work on one side, get the positive side connected up with the positive symbols, get that all done, even heat shrink it, and then go ahead and do your negative so that there's never a time in which you can connect these and cause a short. So I'm going to just leave a couple inches here. And we'll go ahead and slide down a piece of heat shrink. Okay, so just want to make sure you watch for the polarity setting on that. Positive to positive. Okay, if you bring this heat shrink tube up while that's still hot, it'll kind of shrink itself down a little bit. And if this is hot enough, it'll allow you to kind of slide that into that recessed area there and really give some nice protection to that unit. So set that where it doesn't melt anything. So now that we've got the positive side connected, now we can go ahead and cut the negative side and connect that up. Alright, so we've got our connection there. And what we're going to do is we're going to come off of here and connect up a nice Y so we can come from the panel directly into the battery. And then we're going to come on the other side of the Y over to an on-off switch, and then from there to the inverter. Okay, so starting on the wiring harness here, I'm going to go ahead and split right out of the XT connector. This is some pretty high quality wire from Hobby King. It's got silicone insulation on it, so it's really flexible. So I'm going to go ahead and get some solder on the wires here. What you really want to be able to do is get one side of the wire hot, a little bit of solder on your tip, and then kind of let the other, put the solder to the other side and let it suck through. So we got this side done, and we'll just do the same on the other side. And this little harness will be finished. So we got our wiring harness done here, and what we're going to do is we'll connect one side of that to the battery. Nice. And put a little extra solder into that channel this time because of what we're working with. Okay. So now we've got our panel connected to the battery, and we've got our diode in place. So now if we hold this panel to the light, it's now functional. We've got the wiring harness. We're getting ready to get this little inverter prepped. And instead of cutting the frame like I was doing on the first SOLN1, on these version 3s, we can mount this inverter anywhere that's convenient, and we're running a small extension cord over to the edge. We'll get to that. But the real trick on this inverter is figuring out the polarity. You got your DC in here and your AC out here, but you can see that there's really no indication of polarity on this inverter. And if it's anything like the last one that I did, the wiring inside here is actually going to have two different colors. Yeah, we got brown and blue. If my memory serves me correctly, brown was the positive and blue was the negative. Note that on the wiring diagram, but yeah, brown positive, blue negative. So I will go ahead and wire up a connector for the inverter, and we'll need to make a wiring harness that wires over through the switch here. So I'm going to go ahead and connect up the switch here. I'm just going to take two sections of black wire, and I'm going to solder them onto here and put some heat shrink tubing over that, and I'll cut out the frame so we can mount this switch right into the frame. This will be our on and off switch to control the whole system. So we've got the switch here ready, it's wired up, and I'm going to go ahead and mount it in the frame. So this is the first thing we'll cut. You can see we got this area marked out for the switch here. We basically took the side measurements, brought that in, we measured this out. I'm going to go ahead and drill a hole through here, get a hole big enough to get my blade started, and then I can cut this area out. So that's what's going on. Look, you're in. We've got this area cut out here, and there's some little flanges on here that'll snap back down, so we should be able to just press this in here. I may need to still get a little more out. Let me see. There we go. Go ahead and just file the sharp edges on this panel down so that it's safer. And this is pretty soft aluminum, so just a few rubs and you end up with a nice rounded edge there. We got our switch on here. The next step, we're going to go ahead and connect up the inverter, and we've got the watt meter here, and we're going to connect the inverter to the load connection on the watt meter with just another XT60 connector. So just connecting up the plug here and going to the inverter. Just about got it ready.
Have it so you can see.
Yeah, just gonna check the polarity here. So blue to the negative, brown to the positive. Now we have no guarantee that that's going to be the same on all these inverters. We've done 3 so far, and that's the way that's worked out. So my recommendation that if you have a power supply, that you connect this up, set the power supply between 12 and 13 volts, and slowly increase your current, your amperage from 0 on up, and see if this light comes on red and then green. That'd be a great way to test this. But if you don't have a power supply, you could try a 9-volt battery. That'd probably be enough to kick this on at least red on the correct polarity. The connection's done. I'm going to go ahead and shrink the heat shrink tubing. On this one, I just went ahead and put a second piece of heat shrink tubing. I'll come over the connections with. So next thing we'll set up is the connections that go between positive to here, and we're going to bring the negative up and over to this switch. So the negative is going to go over into the switch, and then the other side down into here. This is probably going to be a little trickier just because we have to connect over from the switch so that we actually switch onto the watt meter, which is going to feed the inverter. So what I'm going to do here is I'm going to connect the negative coming over from the switch, the negative of this connector to the negative on our watt meter. So let me get that connected up. I've got all the heat shrink on the wires already. If you don't do that, you'll find yourself having to desolder and reconnect. Okay, so negative from the source over through the switch. The next negative line we're going to connect into here, and it's going to run over to this negative line. And we're going to bring that over into the positive side here, because what we're doing in this case is a little bit different. We're actually using this line switch to power this on and off. So in this case, we're going to go ahead and connect the negative into the positive connection here. I'm just going to double check that I have that turned off so that that switch, if that was turned on, I might accidentally power this device up, but we're going to keep that off. Okay. So the last connection here will be the positive down into our battery pack. But it's not going to connect to the battery pack because of that switch, which is exactly what it's for. Okay, so we have all the connections connected. We have, let's plug in a bulb here to test, make sure that none of these are touching. Before I heat shrink these down, I'm just going to do a quick test and make sure that we're functioning as we expect. So, let's see here. There we go. So that's all good, and we are pulling 10 watts. So we can go ahead and heat shrink this, and we're basically done with all the wiring apart from the AC plug that we've got to put in over here. So anyway, we're almost there, folks.
It's going right now.
So you can see we're building up a unit over there. We got this unit basically finished up here. What I'm going to do is I'm going to run the AC plug out here to the edge, and somebody asked on the forum about this. I'm just going to go ahead and explain it. At Lowe's, I picked up this, it's a smaller AC plug. And the reason is, you probably can't see it here, but yeah, you can. There's a silicone bead along the panel there. And that silicone bead doesn't allow this thicker plug to reach over out to the face. But just, these are 97 cents at Lowe's, and basically you just plug it in here, and now you can come all the way out to the edge of the frame. And I'm just going to take this, and I will basically take a marker pen, draw it around it, and we'll cut this frame. That's what I'm going to do now, actually. So that's the point we're at. Yeah, still video. So one thing you want to watch for in this is that you bring this plug up to the top edge. You don't want it down here, because when you're cutting out, you'll be rubbing the glass with the jigsaw blade. So we want to keep it up here. Now this material is about an 1/8 inch thick, a little less, but that's close enough. So I'm going to go ahead and leave a little bit of room and just see where this plug's coming out. I think I'll split the difference, put it right about there. Alright, so I'm just going to trace around this, the marker pen. And there we go. I'm just going to take any electronics out of here that get messed up with the aluminum shavings. Perfect. Here we go.
You make it look easy.
So now we're just going to take some, get some of the shavings out here. What I'm going to do is I'm going to take this quick drying Gorilla Glue, and I'm going to put it all around this, and this glue expands as it sets. It's going to go in. There's actually 2 layers of aluminum here, so there's a channel, and that glue is going to go into that channel, and it's going to lock this plug into the channel. So you want whatever glue you use in an application like this, honestly, this thing would hold even without the glue. It's in there so tight. But if you do sloppy cutting or something, this glue may be what's going to hold this in place. And you're going to want a glue that expands. If the glue doesn't expand, it's probably going to crack loose. So the idea with the tape is to create a nice dam here to stop the glue from coming out on this side. And that'll make a real nice clean finish around that plug. So a very important step before you put the glue in there. Alright, so I'm just going to go ahead and let the glue fall down around the edges of this. So you can see the space down there in that channel where we're working the glue. And we'll look at this later once that glue sits up, but that's going to set up to just be a bomb-proof plug. Okay, you can see all that white foam that's bubbled up around the socket. That white foam is what's going to really lock that in place. That's going to dry just rock hard. So we're ready to start doing some inside layout here, figuring out where stuff goes. I like to put this watt meter here. You can see that when the watt meter's on, we need to be able to see this display through the ABS plastic on the back. So we'll position that somewhere in there, and we'll just kind of figure out where to lay this stuff out. So, overview. Alright, so we've mounted the inverter with Velcro. We mounted the watt meter down, so everything's mounted. I haven't actually zip tied the wire down into place yet, but what I'm going to do now is I'm going to go ahead and just drill the holes for this handle. We're going to go ahead and mount a handle here, and the hole's just slightly smaller than the diameter of the screw, and because this is a double wall in here, it should bite in real well. But anyway, that's where we're at. Oh yeah, that's nice and tight. So one thing I'm going to do on this, when the screw comes through, I'm going to go ahead and put some heat shrink tubing over the screw. That's just an extra safety precaution so that if components come loose and slide back into the screw, then it won't just gouge into it. So there we go, this SOLN1's coming together. So we've marked out the area for this watt meter display, so we're going to cut this out here, and this hole will line up with the display, and then we can actually see how many watts we're pulling at any given time. So you can see that we've got the hole here lining up with the inverter's fan, so the inverter can get some circulation. There's another hole that lines up here with the light, so you can tell when the inverter's on. And we've got our little cutout here for the watt meter. And now what we're starting to drill is some ventilation holes. We're going to put 6 of them here, 6 in the middle, and 6 up here. And you can do more or less of that depending on where you live. If you're trying to run this in Death Valley to run a little iPad while you watch movies about the Jamaica bobsled team, then you might just want to put more holes in the back of this thing. Okay, so we're going ahead and put in the little standoffs in the back here, these rubber bumpers. So I just drilled a hole for this one, and I'm going to go ahead and pin it, and then we're going to drill the holes for the others. I'm not going to screw this down all the way because once we get all the holes drilled, we're going to want to shake out any of the aluminum shavings. So one of the things I'm going to do is I'm going to basically put this rubber, actually I'm going to go here because we need to get it in the video. Put this rubber standoff here, this rubber bumper, and we're going to just start to drill right through there just to line me up. And then I can take it out and that'll give us a real nice lineup. Okay, on these rubber bumpers here, you want to make sure you don't screw this down too tight because it will pop right on through the rubber. So that forms a SOLN1. We got a single on and off switch, watt meter, single AC plug. Let's pick this unit up and see how it works. So time to do a little test here with the new unit. So we've got power on here, watt meter here, turn on our lights, and it works. We're pulling 56 watts, 4.5 amps. So we did it. We got ourselves a SOLN1 built up here. So for further information, go to www.soln1.com, and we'll post all the latest info there, as well as on laserhacker.com. And the YouTube channel as well. So that's it, folks. That's a finished SOLN1. So it's not a bad project. Something you can do in a couple hours. using basic hand tools and off-the-shelf components. And they'll really make your next camping trip a lot more enjoyable. So that's it, folks. Let's all keep experimenting.